everyone. Today we'll be discussing about second law of motion. Okay, nothing but the Newton's second law of motion. So it states that the rate of change of momentum, the rate of change of momentum of an object is proportional to the net force applied on the object in the direction of net force. Okay, the rate of change of momentum of an object is proportional to the net force applied on the object in the direction of net force. Okay, here whenever the change in momentum, change in momentum is directly proportional to the force. Here instead of force we are considering net force, which means a total amount of force in the direction of net force, in the direction in which the net force is acting. Direction which the net force is acting. Now similarly we have a formula for the above derivation. F is equals to ma. The formula F is nothing but the total amount of force, which is net force. Okay, we can write F, and below that we can write F net also. Okay, so F is equals to ma. M is nothing but mass. Okay, M is nothing but mass, and A is nothing but the acceleration. So now in the derivation, in the definition, we have a term called momentum. Momentum. So what is momentum? Momentum is nothing but mass into velocity. Momentum is nothing but mass into velocity. I can write this momentum into m into v, mass and velocity. And what is the denotation for momentum? Denotation for momentum is P. P is equals to mv is the formula for momentum. Momentum. Now momentum is a vector quantity or scalar quantity? It is a vector quantity. It is a vector quantity. Why it is a vector quantity? Because here velocity. What is velocity? Displacement per time. Velocity is nothing but displacement per time, and here displacement is vector quantity. Hence velocity is vector quantity. So that's why even momentum is a vector quantity. Even momentum is a vector quantity. Now we have two activities, activity number 4 and activity number 5. See, in the activity number 4, the larger the net force, greater the acceleration. So these are the two boxes or two weights with equal amount of mass. So let us consider M and M are the mass for these two blocks. And what I am doing, I am applying certain amount of force on the box, which is F. A certain amount of force. And similarly I am applying a force, greater force. So when compared to this, I am applying more amount of force on this box or in this weight. So what happens? Whenever there is large amount of force, there would be a greater amount of acceleration. So the larger net force, greater the acceleration. So whenever there is high amount of force, then there would be a greater amount of acceleration. Now in the activity number 5, larger the mass, smaller the acceleration. So let us consider these two blocks. It has a weight difference of 1 and m2. M1 and M2, which means they are different in weights. Now I'm applying same amount of force on this box and even on this box. So I'm applying same amount of force on both the boxes. So in this condition, this box will not move with this force, and with this force, this less weighted box will move, which means the larger the mass, small, smaller the acceleration. Okay, larger the mass, smaller the acceleration, or smaller the mass, larger the acceleration. Okay, smaller the mass, larger the acceleration. So this is about Newton's second law. Okay, so now we'll derive this equation F is equals to ma, which is the equation for second law of motion, right? So now in the derivation we know that the net force is proportional to change in momentum per time. Okay, the net force is directly proportional to change in momentum per time. So I'll write this in terms of equation. So F net is nothing but my net force. Okay, F net is nothing but my net force and is proportional to change in momentum. Momentum is represented by P and delta is the change in, okay, the change in momentum per change in time. So this is how I have formed an equation based on the definition, okay. So here change in means the final value minus initial value, okay, the final value minus initial value. So in short we can write it as delta, okay, in short we can write it as delta. Now see, it is not a perfect equation, there is no proportionality symbol, equality symbol, okay, sorry, no equality symbol. So now if I want to remove this and if I need to place an equality symbol, what I have to do? When the symbol of proportionality is removed, a constant is inserted in the equation. So the constant which is inserted is k. Okay, so I am removing this symbol and instead I am writing k is equals to k delta p by delta t, delta p by delta t. So now in this condition, what I choose the value where k is equals to 1. I have chosen the values so that the value of k will become 1. Okay, so net force is equals to delta p by delta t. Okay, delta p by delta t, because I am writing k value as 1 here. Okay, so now we also know that the momentum is p is equals to mv. Okay, this we know the formula of momentum is p is equals to mv. So if I replace the value of delta p with mv, okay, is it possible, right? I can place the value of p instead of delta p. So but I need to have a delta here. So change in momentum is equals to change in mass and velocity. I am inserting a change in a delta symbol over here. So now if I write clearly, delta p is equals to m delta v. So here my mass is not changing, my mass is constant, but my velocity may vary. Okay, my velocity may vary. So now I need to substitute this equation in terms of delta p. So I'll write it as F net is equals to m delta v by delta t, m delta v by delta t. So in this equation you must have observed delta v by delta t, delta v by delta t. So velocity per time is nothing but acceleration. Okay, velocity per time is nothing but acceleration. So instead of delta p by delta t, can I write a? Right, I can write a. So I have the final equation F naught is equals to ma. Okay, I have the final equation as F naught is equals to ma, because change in velocity and change in time per change in time is nothing but my acceleration, So I am substituting acceleration in terms of this terms. So I will get F net is equals to ma, which is force is equals to mass into acceleration. Force and mass into acceleration. Okay. So this is about the second law equation derivation. So now we'll solve example number 3 at wood machine. Okay, example number 3 at wood machine. So see this figure. So here you can observe that there are two weights hanging with the help of a string. Okay, hanging through a string. So here M1 is a greater mass than M2. Okay, the mass of M1 this box and M2 this box. So M1 clearly it is in the figure that M1 is greater than M2. Okay, M1 is greater than M2. So that's why it is hanging below and it is hanging little bit above. Okay, little bit above. So now we'll solve a problem related to this, or we'll derive equation for this condition, for this type of condition. Okay, so now see, for condition 1, for this condition where there is a heavy weight, see, this is my box M1. It has a weight which is acting downwards. I am representing the weight as M1G. Okay, I am representing the weight as M1G, and acceleration is towards the down. Okay, acceleration is acting towards downwards, and it is nothing but a string where there is a tension. Okay, there is a tension in the string. So now see, we know the formula for this condition. F net is equals to ma, right? F net is equals to ma. So here I have this as weight as mg and tension, which are nothing but my forces, two forces. So here in this condition weight is greater, right? Here weight is greater. So instead of this force, instead of this total force, I have to term these two values. So m1g minus t is equals to m1a is the formula for this condition. Okay, m1g minus t is equals to m1a. And now similarly, second condition here is weight is less, m2g, it is less than the tension in the spring. Tension is greater and the acceleration is upwards. Because the weight is less, it is acting upwards. Okay, so now we'll see the formula for this. See, F net, we know that m2 is equals to a is the formula, but what is net force? Net force is nothing but the weight and the tension. So tension is greater, so tension minus weight, T minus m2g is equals to m2a, So these are my two equations. So this is the first equation, and this is the second equation. First equation and second equation. So now I'll equate these two equations. So equation number 1 minus 2 is equals to m1a is equals to t minus m2g is equals to m2a. So here you can see that minus and plus, these two terms will be getting cancelled. Okay, these two terms will be getting cancelled. Now the remaining terms. Okay, so what are the remaining terms? I'll write it down. Okay, so here I have m1g, m2g, and m1a and m2a. So what I am doing, if I need to calculate the value of a, I'll simply write it down once again. m1g equals to M1A, okay, is equals to minus M2G is equals to M2A. So this is the equation. Okay. So I want the value of acceleration. So here we have two terms in the acceleration, two coefficients in the acceleration, m1 and m2, and there are plus signs between them. So A is equals to, firstly, m1 minus, here I have minus m2, which is the coefficient of g, and divided by m1 A plus m2 and here my coefficient A is here, right? So m1 minus m2g, m1 plus m2 is nothing but the value of acceleration. I did nothing, only just I wrote the coefficients together. Okay. So now in the second term I have the value of A, but if I need to calculate the value of t, so what I have to do, I have to insert this complete equation, this complete third equation in equation number 2. So we'll solve it. Okay. So t instead of t minus m2g is equals to m2, instead of A I have to write m1 minus m2 divided by m1 plus m2. Here I have g value. Okay, so this is my equation. So now I have to multiply these terms with this, minus m2g is equals to m1 m2g. I'm multiplying this with this also. Okay, similarly m2 square g whole divided by m1 plus m2 whole divided by m1 plus m2. So here you can clearly see m2g and m2g square, so one term would get cancelled, so now we have to do the cross multiplication. Okay, so m1 plus m2 multiplied with t and m2g. Okay, so now here I'll do it, t into m1 plus m2 minus m2g into m1 plus m2. Okay, so I am multiplying this term with both these terms. Okay, is equals to m1 m2g minus m2 square g. So if I simplify this, I'll write t m1 m2 and here m1 m2g. Okay, this is m1, this is m2 and this is g. Similarly m2 into m2 square, and here we have g, so m2 square g is equals to m1 m2 g minus m2 square g. So now see we have minus over here, minus into minus, and here it would be minus. Okay, minus into plus, minus, right? So now the same terms would get cancelled, like m2 square g and m2 square g, we have minus signs, so they get cancelled. When there is equation, opposite sides with same terms would get cancelled. Now if I simplify this, m1 plus m2, if I send this m1 m2g over right side, here I have minus, I'll get plus, so m1 m2g and plus m1 m2g, which means this 2m1 m2g, and now here I'll send this term from at this numerator to the, if it is multiplying over here, right? So if I send at the right side, it would divide. So I'll remain with the formula. T is equals to 2m1 m2g divided by m1 plus m2, so this is my final equation. Here I have the value for acceleration as m1 minus m2 g m1 plus m2 divided by m1 plus m2. Similarly, I have the value for T, tension, 2 m1 m2 g divided by m1 plus m2 divided by m1 plus n2. I hope you understood this complete equation. Okay, thank you.